let me introduce our speaker. It's Courtney Thompson. So Courtney earned her Bachelor of Science in Chemical and Engineering in 2018 from the University of Alabama. So roll tide. That's where I met Courtney. Nice, some of you who were here in the beginning heard Courtney's story about how we met. She said some nice things about me, so I just want that on record. I was the postdoc, actually got the recruit Courtney. She was in a very competitive cohort. I think we had 15 freshmen apply for like 3 research positions. So she was one of the students that I interviewed and picked to work with us. So she had a very successful 4 years of research in the PAPISH group. So as a student, Courtney participated in the co-op program within her degree. So she worked with SABIC for 3 different semesters in Burkeville, Alabama. It was the polymers industry and bit in oils, I believe, is what you were saying. After graduation, Courtney found employment with ExxonMobil in Houston as an upstream engineer, and then she transitioned to XTO Energy, which is in Midland, Texas. And then most recently, Courtney took a career change, so she moved back over to Raleigh, North Carolina. She's now working with Flowserve as a project manager. So with that, let's see if you can get your slides working. And I'll remind everybody, please mute yourself so we can make sure we're hearing only Courtney.
Okay, let me...
It is.
Okay, can everybody see my slides?
Yes.
Okay, great. Okay, so I've titled my talk, How I Became a Project Manager with Zero Business Experience and a Chemical Engineering Degree. But before I kind of answer that question, I'm going to pose a different question that I'm sure you all have heard a million times before. But that question is, where do you see yourself in your career in the next 3 to 5 years? And just think about it for a second. And, you know, I don't know if you actually came up with an answer. I'll say when I was asked this question in college, and this is a question I feel like I was always asked in college, it's in every single interview, and I feel like I always had an answer. And what's funny looking back is that that answer was always changing. You know, when I started college, I would always say, I see myself as a chemical engineer. And I think I had literally no idea what that actually meant. And then, you know, as I would proceed through college, it would change. You know, I did the research, and so I would say, you know, maybe I want to go get my PhD or my master's, and then I went and did my co-op, and I said, you know, for sure, I'm gonna 3 to 5 years from now, I'm gonna be working at this plant or being an operations engineer, or then I would come back to school and take a polymers class and think it was the coolest thing and say, for sure, this is what I'm gonna do for my career. But I think the reality is that a lot of people don't really know the answer to this question, and that it doesn't always come to fruition in the way that we think. You know, there's always that one kid or that 1% of people who came into college day one and said, I'm going to be a doctor and go to medical school, and they actually did it, and that's what they do for the rest of their life. But I feel like for a lot of us, this question is kind of silly because, you know, you say it and it's important to drive towards something, but you know, how realistic is it actually? And so I just wanted to share my experience with where the direction that I've taken my career, why I've taken it that way, and show just how much, you know, my answer to this question has evolved over time and is still constantly changing. And so, you know, I made this little about me slide, but Deidre kind of already went through most of this. So I graduated from the University of Alabama with just an undergrad degree in chemical engineering. So roll tide, y'all can see here I have this hard hat that an operator made me actually one time. That's all decorated for Alabama. And then this is me. That's the chemistry building, actually, the Shelby Hall right in the back. But while I was in school, I did a year-long co-op with a company called SABIC. I'm not going to talk a lot about this company at all, so I'll mention them here. But I was an operations engineer there, or a co-op. By my third term, I was essentially filling the role of an engineer. So I got some really cool experience there. But that was a petrochemical manufacturing facility. They produced Lexan plastic. So it went all the way from the raw materials to the finished resin. And Lexan plastic is the plastic, it's pretty common plastic. It's used in like the taillights of cars. Huh?
We just had somebody join by phone. Don't worry about it.
Sorry, someone was asking a question. But yeah, so they would make the plastic that's used for cars. It's used in a lot of airplane parts. I think it's actually a super durable plastic and was used to make at a very like high grade the bulletproof glass, which was actually just a plastic, but a super awesome experience. Definitely got my boots dirty working there. But then out of school, I went to work for ExxonMobil, and I worked there for 2 years. So I started in Houston in a new hire program, but I actually did the bulk of that time in Midland, Texas, which is the shale oil play in the United States, where I would say most of the action for oil is in the country. And I was a upstream process engineer or facilities engineer when I worked there. And then most recently, I've made the change to be a project manager in the contracts group at a manufacturing facility for Flowserve Corporation in Raleigh, North Carolina. And so I'm sure y'all are all super interested in the oil industry. So I'm going to spend a bit talking about that. So this picture is actually a picture that one of my good friends took with a drone out in Midland, Texas. And so for those of you who don't know, Midland is the westmost part of, well, not the westmost part of Texas, but it's very west. It's in between El Paso and Dallas. It's 5 hours from both of them, but it's the desert. And it is 100% the oil field. Everybody out there lives, eats, breathes oil and gas. And so this picture is actually some frack sites. I'm sure y'all all have heard of fracking, but the way you can recognize that it's fracks is there's the well pads, and there's probably anywhere from, I don't know, 1 to 4 wells on that pad, and you can see the long line of pumps, like right here, or this line of pumps, and then the silos are full of sand, and the other storage tanks are full of probably some sort of fluid like diesel, or where they mix diesel with water. And basically what they're doing is they're pumping those products down into the wellbore to frack the wellbore and actually get into the reservoir to produce oil. And so since all of y'all are chemistry majors, I think it's important to know where petrochemical products actually come from. You know, the petchem industry is huge. It's where we produce anything from plastics to clothing, obviously, you know, chemicals and oil, but where does it actually start? And so it starts from a reservoir. This is like a pretty traditional reservoir, not really what you would find out in Midland maybe, but you've got pockets in the rock where you have, you know, impermeable reservoir rock at the bottom, and then you've got oil, gas, and water in the reservoir. And what you do is you drill down to the reservoir and you produce it through the wellhead, and then it's just produced from natural pressure in the reservoir, and then from the wellhead it goes directly to a facility where we are essentially separating the components that come out of the ground. So the oil, gas, and water will flow into a production vessel. This is just a pretty typical horizontal vessel, runs around 90 to 100 pounds, and the oil and water will drop out of the bottom. It could be a 2-phase or a 3-phase vessel, and then the gas will come out the top, go through a scrubber, which is essentially just another 2-phase vessel where you can have the gas go on and liquids drop out. And so these products, like I said, go on to industries. Obviously, oil will go on to refineries where it's distilled into different components, and gas will go on to be used as natural gas to produce power. The gas streams that I typically saw obviously aren't just 100% methane. I guess they could be if they're coming, well, not 100%, but they could be just mostly methane. And out of a oil, gas, and water stream, a lot of times they'd be maybe 92 to 95% methane. And so you would have quite a bit of ethane and other constituents that you could use in, let's say, for instance, a big ethane cracker, or a lot of times like condensates or heavy like natural gas liquids will fall out of a gas stream. And those are pretty valuable components as well in industry. And so what did I actually do? What does a process engineer do? So if we go back to this slide, I would manage these facilities directly from the wellhead. So it could be anywhere from, literally 100, 200 feet from the wellhead to a couple miles. But before it would go on to, third parties where we were selling those products. And so I was responsible for debottlenecking these facilities, increasing throughput, and decreasing downtime. And so that means a couple of different things. It could mean managing equipment, so ensuring that compressors were operating or valves were operating correctly. Increasing throughput, finding where those bottlenecks were in the facility. It could be as simple as you have a vessel or a tank that's not cleaned properly, or it could be that you have an undersized line. And so what I have to do is go support operations and identify those issues and help them fix them in a pretty timely manner. And with that, with finding issues, and then also with when new wells were going to be produced, I had to do a lot of modeling of the process flow and of those site capacities. And that was pretty cool. I got to do a lot of pipe phase and HYSYS process modeling. It was like real engineering work. For those of you who don't know what these modeling programs are, they're essentially just softwares on the computer that you can use to model like an ideal system. And so I'll go through like a quick example of something that I did in the field. So this is meant to represent a network of facilities that we had in the field. So these smaller circles represent what we call a satellite facility. So where oil, gas, and water would come directly from the wellhead to these facilities. And then after they were separated, the oil and water and then the gas would flow separately down like a pipeline to what we call a tank battery facility. And essentially that was just a bigger facility, and a battery is used to indicate some sort of storage, but this is the place that it would go before we would sell to like a third party or put it in a bigger pipeline, or would get trucked off kind of thing. And so in this particular scenario, our reservoir and drilling engineers told us, we're going to have new production at these facilities. And so I was tasked with going and looking at this network of facilities and saying, okay, well, what do we need to do to get ready for this new production? And so I had to build a model. I actually built a gas model and an emulsion model, which was pretty neat. But what I did is I started with the rates that we knew were going through the facilities. So a fixed rate at the satellites. And then we had a fixed pressure at the battery. And the pressure was based on what the pressure was in our third-party pipeline. So, we're funneling gas into a big pipeline where every other operator is funneling gas into as well. And so that pipeline might operates typically at like a standard pressure, right? And so let's say it typically operates at 35 or 40 pounds. Well, that's your threshold. You can't be operating your facility any lower than that pressure, or otherwise you're not going to get any gas into the system. And so we would set our last piece of equipment in the facility at that fixed pressure and work backwards and see if we could take the rate. And so I did that, built the model, made it work. It should have worked based on reality, and I actually went and field verified it. So now with operations, and we took pressures all throughout the system, from the vessel at the satellite, at that exit point, to right when it went into the pipeline, to our tank battery, to when we received it at the tank battery, and different points along the way. Field verified it, got it to match, knew it was a trustworthy representative model. And then I kind of went and looked, okay, what are we going to have to change this to be to accommodate the new production? And so I upped those fixed rates, kept that fixed pressure where we knew we wanted it to operate, and then made adjustments to the actual model itself to figure out how we were going to accommodate that production. And so what that allowed me to do was to determine pipeline sizing and determine those facility capacities, and where we needed to make upgrades in the facilities, because the model was indicating, this pipeline or this vessel isn't going to handle what we needed to do. And so that was the very technical part of my job. But on the other side, I actually, when the time came, okay, we have identified these upgrades or these new builds that need to happen, I was the project manager for all of that. And so I was the project manager for all our upgrade projects and new builds. And what that meant is, I scoped and designed these projects. I built budgets. I was responsible for procurement and material coordination. I was ultimately responsible for construction. These were multi-million-dollar projects. And I found that I really loved that project management aspect of what I was doing there. But what did I learn working for big oil? And I'll comment on these pictures really quick. So most of these pictures are from Midland, but these two in the middle are actually from some time I spent in the oil fields in Wyoming, not too far from like Jackson Hole area. So it's beautiful out there. But I would have never thought that there was a whole bunch of oil fields up there. But what did I learn? So I would say the number one thing, and it's kind of, I don't know if cliche is the right word, but the idea that money drives business. And I don't think I've ever been anywhere in my life where that was more evident than the oil field in Texas. Every single company or industry was driven around oil and where the money was and where the capital was. Demand creates supply. And it was also an interesting experience, going through that demand downturn and ultimately oil downturn, and seeing how that affected business and companies, not only in the oil industry, but everywhere. And with that said, money drives business, but ultimately, one of the biggest things I learned is that you have to go after what you want. Your company is going to have, internal drivers. This is what we're going after financially. But in order for whatever project that you're working on, or role that you're doing to be a success, you ultimately have to be the driver of that. And you have to, figure out where you want to find the most success and where you want to spend most of your time at work. And so, that's something that I had to think about when I was working there, is what am I going after, and what do I really want out of my career? And, this opportunity presented itself to get out of Midland and move back to the East Coast, where there's trees and people that don't work in the oil field. And so I had to kind of decide that maybe working for big oil wasn't exactly what I wanted to do. But the opportunity that was presented was something completely different. And so what I did is I kind of honed in on those things that I really liked about what I was doing in my role with Exxon, which was that project management aspect of it. And so I, leaned on that really hard and decided that was the next step that I wanted to take in my career. And so that is how I ended up working for Flowserve. So Flowserve Corporation is a huge global company that makes what's called fluid motion products. And so that means pumps. They manufacture pumps, valves, and seals. They have global operations and customer base. But at Flowserve Raleigh, we actually manufacture mostly nuclear and commercial gate, globe, and check valves. So I've pictured some of the valves on the right that we actually manufacture at the Raleigh site. And so I'll talk a little bit more specifically about those valves. So the flagship valve that Flowserve Raleigh manufactures is called the Edward line main steam isolation valve, or main feed water isolation valve. And so we're totally shifting gears here, but to get into nuclear facilities, I don't know how much y'all know about those, but at a very high level, how a nuclear plant works. So, you can have your boiling water nuclear reactors, or the pressurized water nuclear reactors. The fancier, I don't know how new they are, but the newer iteration of that is the European pressurized water reactor. And at a high level, what they're really doing, obviously, is you have a reactor, and in the reactor, you have nuclear fission occurring, and that produces heat, and that heat, heats up water and turns it into steam, and that steam will drive a turbine that drives a generator and produces electricity. And so in that system, the valves that we manufacture at Raleigh are part of that water steam system, and they're one of the major safety components. And so what they're designed to do is either cut off that flow of steam to the turbine, or cut off the flow of feed water into the system. So this is what those valves look like. And just for a bit of context in terms of size of this valve, this section right here is the actual flow path for water or steam. And we manufacture them up to an ID or inner diameter of 42 to 46 inches. And so a person standing next to this valve would be dwarfed with all the actuator assembly and everything. And so just some specs on the valve. They're designed for extremely fast closure, 2 to 5 seconds at high pressure and temperature that you would find in a nuclear facility. It's a gate valve and a stored energy hydraulic actuator that creates a lot of reliability on the system. You want these things to always work. The gate in the valve is actually comprised of 2 independent flexible wedge halves, and what that means is that it gives it a little bit more give when you have some sort of physical or thermal stress on your pipe, just to ensure a seal. And then the valve will seal bidirectionally as well. And that was all very technical, but what's interesting is that my job right now is very not technical, and I'm a project manager. So what I do is my team gets the high profile projects or programs where we have a customer. Let's say, for example, a new nuclear facility is being built, and a customer is going to come in and place a multi-million-dollar order for these valves. And nuclear valves have very stringent code requirements. So they have a lot of quality points, a lot of customer interaction and manufacturing. And so I would be the person who would take one of those programs with the customer and manage it through the project life cycle. And so I'm responsible for managing project deliverables and key stakeholders, both internally and externally. I act as that customer touch point between our manufacturing facility and those customers. I am ultimately the owner of our contracts with those customers. And so if anything is evolving or changing, I have to make sure that we are meeting our obligations and reporting our financials. And then I also do a lot of risk mitigation. And so that's a really fancy way of basically saying, if we're identifying some sort of issue or something that might come up. So let's say, for example, we have a supplier who's going to supply an actuator or even like a casting of a valve, and we see some sort of issue. I have to be able to identify those issues when they become potential issues and attempt as much as possible to mitigate those risks from affecting the project. And so with this job, because I'm now a project manager, I'm going to get to do some cool training. So this year I am going to be getting my what's called a Pmp certification. It's basically just an industry standard project certification. And then I'm looking into getting my MBA in the future. And then I also wanted to put up here, Flowserve is actually working to pull together a newer, it's not newer, it's actually like revitalizing an older program called the Flowserve Ignite program. And so this is a project management, supply chain focused program where it's a university program where participants would come through and do, I think, 3 rotations. And so, this is something that if you have any interest in project management, being in a manufacturing space, having that technical background is really important. So with all of that said and all of my experience shared, I want to pose the same question that I posed at the beginning, but kind of a different way. So do you think you know where you will be in your career 5 years from today? And then I'm going to pose the question that I posed at the beginning of my talk. how did I become a project manager with 0 business experience and a chemical engineering degree? And I hope that you can see kind of that the connection here is that you never really know where your career is going to take you. And what I would say is don't be discouraged if your path changes, or you start your career and you don't end up loving what you're doing. What I would recommend is that you lean into the aspects of what you do that you really enjoy, or find those things to lean into that are important to you, and really be that owner of your career and drive it towards what you want at the time. And then also just note that in my experience, there's certain skills, both technical and business skills, that you can learn in any role, in anything you're doing. And some of those skills are applicable to any job you would work, or any industry you would work in. And so what I would recommend is that you, regardless of what you do, that you find those skills and you focus on them, because you never really know where your career is going to take you. And it's kind of important, I think, to always be thinking about the big picture, and be thinking about what you're good at and what you enjoy. And I think that will help you find the best path for your career to take. So that's pretty much all I have. Go back.
All right. Well, we can go into a Q&A then. Of course, we always like to encourage our students' questions first. So I do have a few students who have not asked a question of our speaker. I could pointedly count on them, but it looks like Beck's got a question.
Yeah, so you talked about wanting to go back to school. If you were to do that, what kind of degree would you be looking to get? More in your chemical engineering or a different area?
So I've actually been considering recently going back to get my MBA. And the reason that I say that is kind of what I was touching on, that I think where my career is taking me right now, an MBA would give me that mindset to be able to go into any industry. I do enjoy being in a technical industry, but being able to see the business side of things. The role I'm in right now is very, I'm a project manager, so it's very business heavy, and the aspects that I would say that are a little bit more challenging for me are the contract sides of things and the financial sides of things. And I think that having a true business, a real business degree would help me a lot in, understanding what's driving, the financials at the Raleigh site or within the corporation.
Other questions? Maybe from Alex Van Nelson or Morgan Radzius.
All right, so with that MBA, where would you want to take that? Called out.
I think right now I'm looking at the role that I'm in, and how it would help me. I think, it's kind of funny you asked that, because I feel like at this point I'm starting something new and I'm trying to focus on what I'm doing. And so I see that MBA as, maybe the right next step, but it's kind of hard to know. I think something that I would love to do, like in the future is to actually go into teaching. And so what I kind of see myself doing long term is leveraging my chemical engineering degree and the technical background that I have, but staying in these kind of business roles and you know, advancing my career, and maybe 20 years down the line going back in and being able to teach in a business setting.
So Courtney, I know you've only been with Flowserve a few months here. How often are you finding, you know, orders coming in for valves for new nuclear facilities, or is it more replacement for old facilities that are upgrading?
That's a good question. For a nuclear valve order, those are year-long orders. So one of the orders that I'm managing right now actually is for a facility in France. And that plant, the original order came in 2007 or 8. And so I'm still managing those same original orders, where we supplied a whole bunch of, you know, those main steam isolation, main feed water isolation valves, and they're continuously needing spare parts or MRO parts for those orders. But they're actually ordering new valves. But I think, you know, the facility is getting new valve orders every day, because we do both commercial and nuclear valve orders. I think that the nuclear valve orders are definitely less frequent because it's such, the code for nuclear facilities is so stringent that when a company comes in to get an order from us, it's not as simple as, you know, issuing a PO. It's, we have to make sure that you are getting the correct, supplied from the correct places that, you know, me as the customer would want those supplies to come from, and I have to make sure that I can be part of your process within that manufacturing. And every single customer has different requirements and different codes. So like the code in the US follows what's called ASME code, but the code in different parts of the world, so like in France, it's called RCCM code, and I think the French are still trying to figure out how to build a plant to RCCM code, because it's so, the requirements are so strict that it's difficult to find plant facilities that can actually supply what they need. Yeah.
Well, I have more questions, but is there any other questions out there?
So when people, like, nuclear plants order these valves, are they kind of like ordered to be customized for the plants? Like,
Yes.
Are they different for each customer?
Yeah, so every single valve, nuclear valve that we make in Raleigh is what's called a made to order valve. So it's not, the facility is not an assembly line. It is, every single valve is special or unique in some way. And a lot of that, like I was mentioning, has to do with the particular code requirements. But there's a lot of, you know, quality of those valves is very important. And so every single order is pretty unique, and every single order through the shop kind of has a little bit of a different path.
I've got a question. So since they're all specially made, how much testing goes into each of those valves? Like, do they have to go through like a lot of different things, or?
Yeah, so for reference, the valve is comprised at a very, you know, high level. You've got the valve body, the valve bonnet that sits on top of the body. You've got the gate that actually goes into the valve to create the seal, and then you've got the actuator. And so we manufacture all of that in our facility, and every single one of those components and all of their, you know, constituent components has testing requirements. And so, for example, the actuator that I showed pictured was kind of like a domed structure. And so I have what's called a hemisphere, so the top of the dome, going through the plant right now. And its testing requirements alone is taking months to go through the shop. And the reason is because, we'll do, machining of the hemisphere, and then it requires a what's called a magnetic particle test, or like an X-ray. There's a lot of different testing requirements, and a lot of those different testing requirements have to be witnessed or inspected by the customer. And then you end up doing that for every single part of the valve. And it's very dependent on, what the code that you're building the valve to is, or who the customer is, in terms of like how much testing you have to do.
So you worked in the big oil area, and now you're working around nuclear energy. And I know these aren't huge topics that we talk mostly in general terms in the academic world. So how much learning did you do on site? How much was that structured training through your companies, and how much of it was you doing background information searching yourself?
That's a good question. So I think in both industries, it's constant learning. The industries are always changing, but both industries have been very good about kind of teaching me on the job. When I started with ExxonMobil, I actually hired into like a new hire program where they let me work with operations. And so that's when I said I went and worked in Wyoming. I actually did like a whole program where I was doing nothing but going and learning about the industry, because you're right. Like I had a chemical engineering degree, kind of structured in a lot of ways towards the petchem or oil and gas industry, but we never ever talked about, a wellhead or anything like that. So it's a lot of learning, and I don't think I would enjoy a job where I wasn't constantly learning. And so I think that's a really good part of the industries that I've worked in. Sorry if there's noise. There's definitely something going on in the hallway of my apartment complex.
I don't hear anything coming through. Any other questions?
Well, I have an answer.
Okay.
To ask you a question right at the front, what do you see yourself doing in 5 years? I'm going to be retired.
Love that.
Feet are going to be up, the beer is going to be cold, and I may even be watching television.
That's funny. Wow.
Dave will still be writing manuscripts in 5 years, even though he'll be retired.
Yeah, but only books.
Books.
It's so funny working in industry, especially working in oil and gas. People who would retire always came back. Like they always came back in some sort of either like just came back or were consulting or something like that. I think it's fun being around the chemistry or being around the engineering, and when you go home, it's probably kind of boring.
I think we're all scientists at heart, so we're always going to be curious and engaged. Otherwise, we wouldn't be in the business.
Very true.
Oh, it seems to be a natural lull. If there's any other last-minute questions. Okay, with that, I will close our seminar. So thank you, everybody, for attending. Thank you very much, Courtney, for a great talk.
Thanks, guys.
All right, so we have another couple talks. We have 3 more speakers before the end of the semester, so please tune in on Fridays. Thanks again, Courtney.
Thanks, guys.